This is the final project for BE309, Bob Roach by Group 11. The goal of this project was to create a human-cockroach interface that would allow a human to paint on a canvas using a cockroach leg. The cockroach leg would be controlled by a Myo armband and 2 sliding potentiometers. An additional sensor and a servo would be added to the system to create a paint plate that could provide different color options to the cockroach. The system can be broken down into 3 parts. First, the box with the sliding potentiometers. Then, the first MIDAC that will be controlling the sliding potentiometers, and the second MIDAC that will be taking in the force sensor readings and providing an output via a servo. The MIOBand read in both EMG and forearm orientation. EMG was used to determine whether or not the human had made a fist. Forearm orientation determined the location in space that the cockroach leg needed to go to. It used a quarter ion system. An additional interface of a force sensor used load to determine what paint color the user wanted to use.
In the system setup, we first create a coordinate plane frame of reference by tapping our fingers in each corner of the frame we want. The coordinate system is translated to Euler space, where we extract x and y values that are used to control the slide potentiometers. The MIOBand library processes the MIOBand EMG signal that triggers leg extension. The load from the force sensor is processed by the MIDAC and used to control the servo.
Hello, this is Casey, and I will be discussing the methods utilized for the effectors, which output a response that will carry an output from the processor to the external setup of the painting cockroach. There are 3 elements of this: the cockroach leg, which will be controlled by the information sent from the MIOBand, which is then processed by the MATLAB code in the MIDAC. Fist recognition will lead to an output of a sine frequency, which allows the cockroach leg to extend to touch the canvas. The sliding potentiometers are controlled by the H-band, which is also processed through the MATLAB code. The resulting analog outputs will control the flow of electricity and cause the potentiometer to move in the X and Y directions. The force-sensing resistor will be used to actuate the servo motor. Different forces will correspond to a specific rotation and color for the paint.
Hi, my name is David, and I'm going to be talking about the results. So overall, the measurement and the processing of signals worked well, and the system's components worked well in isolation. Once the project was put together, the cockroach leg responded to the fist gesture, and the color palette did move according to the pressure sensor. The device was fully functional for a few moments, but unfortunately the servo motors were not strong enough to overcome the friction of the device for too long, and therefore this functionality was only maintained briefly. And a potential solution to this issue would be to use 2 sliding potentiometers to add the additional power and therefore overcome this friction. The morning of the demo day, the group contemplated replacing the sliding potentiometers with servo motors that would yield more controlled but more restricted motion. And the group decided to go all in the implementation of the sliding potentiometers. I'm going to hand it over to Nick, who's going to talk about the discussion.
As the sliding potentiometers were not successfully coordinated with the MIOBand to create one-to-one movement. However, the force sensor and servo collaborated as planned, as did the movement of the leg in response to forming a fist with the MIOBand. All parts fit well into the actual laser-cut frame. Possible improvements include 2 servos with full 360-degree motion rather than sliding potentiometers, or 4 sliding potentiometers rather than 2 to deal with the heavier-than-expected parts.
Hello, my name is Casey, and I will be presenting the conclusions for Group 11. After completing Bob Roach, we concluded that the human-machine cockroach interface that was created highlights the potential benefits of utilizing signals to detect and react to the surrounding environment. A pressure sensor was successfully utilized to rotate the servo in order to present the cockroach leg with a specific color. A MIOBand was also effective in translating EMG signals and translational motions to the cockroach and the sliding potentiometers. The success of the EMG signals and the corresponding cockroach leg response shows that it is possible to utilize signals from the muscle to create a contraction or extension of the cockroach leg, which is relevant information to the field of prosthetics. The sliding potentiometers were not as effective as other elements of this project. However, that was a result of mechanical issues. Future research should be conducted that can address new and more effective ways to move cockroach leg in the X and Y plane. There were also limitations in the material that was utilized, which made it harder for the sliding potentiometers to work. This can be further looked into, and perhaps alternative materials can be utilized. Overall, the prevailing elements of the project were successful, and this information can be used to help develop prosthetics which can actively respond to the environment.